A matrix is just an array of numbers. We use them to solve our systems of equations. We talked about the size of a matrix. When we do size, it's rows by columns. If I asked you to find the values of all variables to make these matrices equal, all right. The answer is probably what you would guess if I just gave you this problem and asked you to answer it. Matrices are only equal if every entry is the same. So what would my x have to be? 2. X is in row 1, column 1, so it would have to equal the number in row 1, column 1. So my x would have to be a 2. We have to have the same position. So y is in row 1, column 2. So it would equal the number in row 1, column 2, which is a 1. What's P going to equal? And Q? So they're only equal if they're in the same number in the same position when we're comparing two matrices. All right, some operations we can do with these matrices. We can add, subtract, multiply by a constant. We can add combinations of these matrices. So that is what we are going to practice. A lot of times the matrix will be named with a capital letter. So for this one, sorry, did everybody get the last one down? Okay. So matrix A is here. You notice this matrix doesn't have the vertical line. That means it's not necessarily a system of equations. It is just some other array of numbers, but we can treat it the same way. If you want to add or subtract matrices, they have to be the same size. So what is the size of matrix A? 2 by 4, and matrix B? 2 by 4. If they were different sizes, then you would just say no solution. You couldn't add or subtract them. So if I ask you to find A plus B, you're going to add two matrix, you will get a matrix. These were both 2 rows and 4 columns, so your answer will be 2 rows and 4 columns. What do you think I need to do to get each of these?
Same locations.
Add the corresponding numbers. So for the first entry, row 1, column 1, you add the numbers in row 1, column 1. So 2 plus -3 is -1. So for the next one, we do 4 plus 4, which is 8. 8 plus 0 is 8. -3 plus 1 is -2. And you go to the second row. 0 plus 6 is 6. 1 plus 8 is 9. 2 plus 2 is 4. 3 plus 0 is 3. Just like any other time when we subtract, order matters. So A minus B will be different than B minus A. So all of that means is we subtract corresponding entries. So 2 minus -3, 4 minus 4, 8 minus 0, -3 minus 1. Second row, 0 minus 6, 1 minus 8, 2 minus 2, 3 minus 0. Is everybody okay with adding and subtracting matrices? I'll give you a second to write down these matrices, then we're going to do a few different things. So the first thing I'm going to ask you to find is 4A. What do you think that means? You take everything in A and multiply it by 4. So every single entry. So that gives us 12, 4, 20, negative 8, 0, 24. Alright, next one. I asked for 1/3 C. So all that means we take everything in matrix C times 1/3. So 9 times 1/3 is 3. 1/3 times 0 is 0. 1/3 times negative 3 is negative 1. 1/3 times 6 is 2. The last one, I asked for 3A minus 2B. Okay, you may not need to show work here, but if you're at all confused, we could go ahead and write down, what would 3A? Okay, so if I just did that, everything in matrix A times 3, what do I get for my first row? 9, 3, 15, and the second row would be negative 6, 0, 18, minus, okay, 2B. So if I take everything in matrix B times 2, we get 8, 2, 0, 16, 2, negative 6. Everybody with me there? Now all we're doing is subtracting. Both of these matrices are 2 by 3, 2 rows, 3 columns, so we can subtract. So 9 minus 8 is 1, 3 minus 2 is 1, 15 minus 0, 15, negative 6 minus 16, negative 22, 0 minus 2, negative 2, 18 minus negative 6. So 18 plus 6 would be 24.
On the coworking test, do you want us to like fill out the 2 different matrices, or can we just put it all together?
You can put it all together if you want. Alright. Are we okay with the adding, subtracting, multiplying by constant, all that good stuff? The last thing we need to talk about with matrices is multiplying them. We are not going to get into dividing matrices, but we will multiply 2 matrices. However, it is different. You do not just multiply corresponding numbers together. So to multiply, we have to take a row times a column. When we do that, we know rows are horizontal, columns are vertical. We will actually get a single number. You multiply the first numbers together. So we'll do 3 times 3, which is 9. We'll multiply the second entries. So negative 5 times 4 is negative 20. We multiply the third entries. So 2 times negative 5 is negative 10. But then we actually add all of those numbers together. And we get negative 21. So when you multiply a row times a column, you get a single number for your answer. For our matrices, in order to be able to multiply 2 matrices together, we can't just say they have to be the same size. We have to be able to take columns times rows. So in order for us to be able to multiply the matrices, the number of columns in the first will have to equal the number of rows in the second. What I will have you do is write the size of them. So if the first one is an n by n matrix and the second one is an n by L matrix. In order to be able to multiply them, the number of columns in the first has to equal the number of rows in the second. So those two numbers have to be equal. That tells me I can multiply them. And the dimensions of the final answer will be the other two numbers. So I can multiply them because I have n columns in the first and n rows in the second. And when I multiply them, my final answer will have m rows and L columns, whatever those numbers might be. I want to find A times B. Order will matter on multiplying matrices. So unlike in general with multiplication where you can flip the order, you cannot here. We have to check to make sure that we can multiply. So what is the size of this first matrix? 2 by 3. What's the size of the second one? Okay. These threes match. That tells me we can multiply them. And my final answer will be what size? 2 by 4. So my final answer will have 2 rows and 4 columns. Could I do B times A here? No. Matrix B, if I flip the order, matrix B is a 3 by 4, and matrix A is a 2 by 3. So could I multiply them? No, those numbers don't match, so it would be impossible to do it that direction. Okay, to help us out, I'm going to show some work here. This entry, this is row 1, column 1, correct? So to get that, we will take row 1 times column 1. When you multiply those, you multiply the corresponding numbers. So 2 times 2 is 4, plus 4 times 4 is 16, plus -1 times -3 is 3. So when you take a row times a column, you multiply the corresponding numbers, we add those together. Okay? You can go ahead and add it right now. I'll probably just copy it down in a second and go ahead and add them together. If you are comfortable going ahead and writing your answer, that's fine. I'm just trying to show you guys as much work as I can for where my numbers are coming from. Next. This entry right here, this is row 1, column 2. So to find it, you have to take row 1 times column 2. So multiply the first numbers. 2 times 5 is 10. Second numbers, 4 times 8 is 32. Third numbers, -1 times 1 is -1. This is the entry in row 1, column 3. So we take row 1 times column 3. So when we do that, 2 times 1 is 2. 4 times 0 is 0. -1 times -2 is 2. This entry is row 1, column 4. So we take row 1 times column 4. So So 2 times 4 is 8. 4 times 4, 24. -1 times -1 is 1. Does everyone understand how I got those numbers? Next, I need the number in row 2, column 1. So take row 2 times column 1. So 5 times 2 is 10. 8 times 4 is 32. 0 times -3 is 0. Now we need row 2, column 2. So row 2 times column 2. So 5 times 5 is 25. 8 times 8 is 64. 0 times 1 is 0. Next we need row 2, column 3. So 5 times 1 is 5. 8 times 0 is 0. 0 times -2 is 0. And my final one, we need the number in row 2, column 4. So 5 times 4 is 20. 8 times 6, 48. 0 times -1 is 0. And so now to finish it, you just add your numbers together. So the first row will be 23, 41, 4, 31. Second one, 42, 89, 5, and 68.
Row 1, column 4 will be 33.
Yeah. Did I subtract one? I think I did. Thank you. I just want to spend the rest of the time, I want to practice a few more of these multiplication problems, if that would be okay with everybody. And then that's really all we have for today. So let's just practice a few more of these. What are the dimensions of the first one? And the second one? So can we multiply them? How big will my final answer be? Okay. First we need row 1, column 1, so row 1 times column 1. So we get 2 times 2 is 4, -2 times 3 is -6. And we need row 1, column 2. So 2 times 1 is 2. -2 times -1 is 2. Row 1, column 3. So 4 times 2 is 8. -2 times 3 is -6. Row 1, column 4. So 2 times 6 is 12. -2 times 2 is -4. Second row, row 2, column 1. So 2 times 1 is 2. 0 times 3 is 0. Row 2, column 2. So 1 times 1 is 1. Negative 1 times 0 is 0. Row 2, column 3. 1 times 4 is 12. 0 times 3 is 0. And row 2, column, sorry, I did 4 times 3, didn't I? Did I say 4 times 1? Or did I say 4 times 3?
You said 4 times 1.
And row 2, column 4. So 1 times 6 is 6, and 0 times 2 is 0. So add those together, we get negative 2, 4, 2, 8, and 2, 1, 4, 6. You guys ready to try one? Two by 3, and this one is 3 by 2, so we can multiply them, and how big is our answer? 2 by 2. Okay, so row 1 times column 1, you get 1 plus negative 2 plus 6, which gives us a 5. Row 1, column 2, so you get 2 plus 0 plus 12, which is 14. Row 2, column 1, so row 2 times column 1, you get 0 plus 1 plus 8, which is 9. And row 2, column 2, you get 0 plus 0 plus 16, which is 16. Do we get that one? Just a couple questions here. I might ask you to add two matrices where you have some variables in there. You don't have to have only numbers. You just add corresponding positions and combine like terms as possible. So for the first entry, row 1, column 1, 3a plus a is 4a, 1 plus 4 is 5. Row 1, column 2. Can I add 5 and b? So I'm just going to write 5 plus b for that entry. Row 2, column 1. b plus 1, can we do that? No, so just b plus 1. And the last one, 2 plus 4 is 6. So you can, they don't have to be just numbers. You can have variables, you can have expressions in that final answer. And last one. What am I asking you to do with these? What's the operation between those two matrices? Multiplication. So if I'm asking you to multiply, what's the size of the first one? And the second one? We cannot. This is no solution. We cannot do that. All right. That is the end of what I have today. So game plan, moving forward, there is a handout posted on Classroom for this section. Tomorrow we are just taking a review day, and I'd like to do a test Friday. I don't think we want to wait until next week to do it. I think we'd probably rather do it before the weekend. It's a pretty short one. It's our systems of equations, so substitution, elimination, the inequalities, so graphing and shading, and then the matrix stuff that we've been doing. So tomorrow will be a review day, and I'll give you a study guide. Does anybody want that study guide today? Okay, I'll go ahead and pass out the study guide today, and then tomorrow we'll just